Continuing the arithmetic power hour, we're now working on the second topic of the day, which is ratios. Remember again that a ratio means the answer you get when you divide two numbers. And a ratio is also used to compare the relative size of two numbers. So if one thing is 3/5 as long as another, then you can say that the ratio of one to the other is 3 to 5. Remember that when we write these, the order is very important. So when we see a statement like the ratio of A to B is 3 to 5, we have to make sure that we put the right numbers in the right places. A over B equals 3 over 5. I wanted to show you an alternate way of writing this. When you see something like the ratio of A to B is 3 to 5, an alternative way of setting this up is by using a dummy variable x and rewriting it this way. There's some unit out there called x, and maybe we don't know how big it is, but A is 3 of them and B is 5 of them. So if you want to think about this bar as being one of your x's, if we put 3 of these x's together, that gives us A. Whereas if we put 5 of them together, x, 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 that gives us quantity B. So that makes it very clear what the concept of ratio means. And you might think that this only confuses the matter because now we have another letter floating around. However, sometimes when we go to set up an equation, it'll be much easier when we have something like x to use as the name of some quantity. So let's take a look at that next example involving the triangles. And this one is actually going to involve a multiple ratio, not just the ratio of two numbers, but the ratio of three numbers. The three sides of a triangle have a ratio of 2 to 3 to 4. Which is drawn here. The three sides of a triangle have lengths in the ratio of 2 to 3 to 4. And then suppose that there's a question that asks for the perimeter of this triangle, which means the distance around the triangle. And the question would be, what is the longest side? So many students really get baffled by this kind of question because they see the numbers 2, 3, 4, and they draw a triangle that has short, medium, and long sides, and then they label them with 2 and 3 and 4. And then if you add these numbers together, you get 9. Oh, actually, I'm going to change this number to a 36 to make it a little easier. Anyway, if we add these numbers together, we get 9. And then the student says, okay, the perimeter of this triangle is 9. And then they see this, the perimeter is 36, and then they just get really confused. So we have to remember that the 2, the 3, and the 4 are not the absolute lengths, but the relative lengths. They're just comparative. So it just means that there is some dummy unit x. So this number is not 2. It's not literally 2. It's 2x, 3x, 4x. Okay, so you can kind of imagine if x is like this long. So there's 2 of them, and there's 3 of them, and there's 4 of them. Now that we have these sides labeled, we know that if we add those numbers, we get 36. If you add these together now, you don't get 9, you get 9x. And that tells you that x itself must be 4. Then if we go back to the triangle, the question was, what is the longest side? Okay, well now we know that x is 4, and 4 times 4 is 16. So the multiple ratio could be very useful for things like this question. A multiple ratio is also very useful when we have two parts and a whole. The part to whole ratio. Again, this problem really baffles people if they've never seen it before. It's a simple question. It's not that hard to answer, but let's talk it through. And I'm going to be looking at the question about cars on your handout. There are 12 black cars for every 20 white cars. In a garage full of 128 cars, how many are white? So here's the question on the board. If there are 12 black cars for every 20 white cars, there are 128 in the whole garage. How many of them are white? Okay, so remember that obviously this doesn't mean that there are only 12 black cars and 20 white cars in the whole garage, because there are 128 in the whole garage. This is a ratio, these are relative numbers. So therefore, we know that the number of black cars is not literally 12, but is 12x. The number of white cars is not literally 20, but it's 20x. And if we add these together, we get 32x. Okay, so this is the ratio of part to whole that I was talking about. The ratio of the part to the whole is 12 to 20 to 32. And then we're also given that the total is 128. So that's a very easy equation to solve. X equals 4. That basically means that there are 4 groups of cars. Each group has 12 black, 20 white, 32 total. There are 4 of those groups. Okay. And the question was how many white cars? Well, if you have 4 groups and each group has 20 white cars in it, then the number of white cars must be 80. Just as an alternative way of approaching this, you never know, it might be useful on some other problems. We can think about this as a 3-part ratio, black to white to total, which would equal 12 to 20. And if we add 12 and 20, we get 32. And then, of course, in this problem, we are also given that the total number of cars is 128. So we can replace that with a 128. So we can turn any one of these into a proportion, any 2 of these fractions into a proportion. So basically, in order to solve the number of white cars, maybe we could work with this part of the proportion. W is to 128 as 20 is to 32. I like to reduce fractions. We can divide each of these numbers by 4. And we can divide each of these numbers, I believe, by 8. And then we cross multiply and we get W as 80. We're really doing the same thing. The mathematical principle here is just a proportion, but it looks different on paper. Some people prefer one way of looking at it over the other. And depending on the question, maybe sometimes it'll make more sense to set up these problems with the x, the dummy variable, and sometimes it'll be easier to just keep it as a 3-part ratio.